Welcome back, gangies. We're back once again. This is the hyperbolic suffering chamber. Sadness pervades every corner of our lot. Okay, things aren't that bad, but I'm definitely very, very tired. So, yeah, this week and last week I've just been very tired. So, hopefully we'll figure something out there. If not, we'll be looking to the Discord to find someone who will take over what's going on, because someone has to hold the torch. So hopefully we can pass the baton to Thomas, Copy Ninja, Nix, who knows, someone in Discord. Maybe we'll pass it to Elon. We were talking last night. I've been having some trouble sleeping. He was having some trouble sleeping. We've just been talking late at night sometimes. So yeah, that's where we're at. So lot to be done. More LeetCode to be done. I feel like the last 30 days or last 40 days, I can't even tell. Recently, I feel like we've just been on autopilot, which is probably good. We're locking into the grind, which is always a good thing to see. We've also been able to make progress on a lot of other things recently, which has also been awesome to see. But at the same time, it has been difficult to stay. I'm not exactly certain. I'm just tired. I think maybe we need a break. But there's no such thing as breaks over here. I don't know if it's a break. I think we just need to manage our time better. I need to get more sleep. And yeah, I need to do things in a better way. So that's where we're at. That is where we're at. I wonder if I'll look back on these videos and realize I was a madman. Or I'm not exactly certain. At least we'll have 200 pieces of videos. It'll be interesting to see how this works. If I were to die tonight, or by some freak accident or something, it would be kind of cool that my descendants would be able to watch this video and be like, dang, this guy was strange. So that'd be kind of cool. But who knows, right? Who actually knows? That being the case, we should probably figure out a way to make our sleep schedule make sense. I don't feel tired though. It's not like a sleep. Who knows? Maybe it is a sleep tired. I slept on the floor for about 15 minutes yesterday, and it was kind of incredible. So that was kind of dope. It was actually quite incredible. I wonder if my bed is garbage. And it probably is that. That probably is the case. I don't know many people who would say that the floor is more comfortable than their bed. But I don't feel tired today. But it might be one of those weird things where like I'm such in a daze that I can't tell that I'm tired. But yeah, definitely feel tired. We have to do some LeetCode. We have to do this LeetCode right now. Then we have to work out. Then we have to read. Then I have to do some extracurricular stuff. Some extracurricular learning for work. And then we're going to do some personal learning for some other stuff, which is pretty exciting. But there's still more to squeeze out of the day. So yeah, that's exciting. I would idealize a world where we could sit down and do one thing a day, but maybe the modern hominid wasn't born to do one thing. Maybe if you are an anomaly, if you can do one thing, right? 'Cause maybe there's some wandering attention that's integral to human nature. So maybe if we can do one thing all the time, maybe that means something's wrong. But I'm not certain. I think we're just bouncing around. But yeah, I think it would be ideal if it's 7:47 right now. And I started feeling this way after I think I got a couple long meetings today, but I think if we can get to bed by 11, that would be ideal. But I know it's not gonna happen. This is a pipe dream. We're not gonna get to bed by 11. It's just not gonna happen. So we might as well throw it out the window now and just accept our fate. Hopefully, we'll fix it this weekend. So that's probably important. I also didn't eat yet, so we got to figure that out. They think this is a mess. Maybe I'm not tired. Maybe I'm just malnourished. I haven't been eating much, and that sounds bad, but I usually eat one meal a day, but I didn't get groceries yet, so not sure what I'm gonna eat tonight. I think what we do need is Huel. Huel optimizes eating away. Okay, it automates. If I could just drink a perfectly engineered drink of powder that, you know, gets you everything you need and doesn't make you feel like garbage, that would be ideal. And that is what Huel is. But unfortunately, you need Bezos level money to afford it. It's just not sustainable as a long-term sustenance, long-term food sustenance route. I mean, the amount of bottles you get per box, per shipment, per like dollar is just not economical. So yeah, that's where we're at. We will see how this session goes. I think we're still going to go easy and do 20 minutes, maybe 25, maybe 30. I said 20 yesterday, but we still ended up doing more than that. But yeah. Something's going to give. So that's where we're at. I'm actually really tired. We're going to jump into it and power through. And I think we should be able to get where we're going. So, strangely enough, I feel like this is going to be a good session, but we shall see. So that's kind of where we're at. And also, I think we have a comment, actually. Or maybe we don't. I'll double check. I think we do indeed have a comment. We do. We have a comment from Solid Akram Joy. Awesome name, awesome profile, an even better profile picture. Oh, wait, it's Demon Slayer? Oof. No. I'm just joking. It says your regular videos inspired me to solve LeetCode problems again. Feel strong, man. In the last 7 days, I have solved 12 of 13 easy array problems. 12 of 13. Let's go. I hope that I'll be more consistent like you. Thanks and regards. Hey, I'm just trying to get like you, brother. We just gotta stay consistent. The rewards of discipline far exceed monetary gains. But monetary gains are nice. So we'll see how it goes. But yeah, that's awesome. Yeah, I mean, that's awesome. I think this comment will carry us through the session. So shout out to Salah Akram Joy for getting us through today's session. And yeah, hopefully we can make a lot of progress. And yeah, that's just awesome to see. So we're just trying to get like Salah here. And that's how it starts. A little bit a day goes a long way. One day, Saleh and I will be looking back on our massive long list of LeetCode problems solved, and we'll be sitting back in the Bahamas, you know, wearing gold slippers and gold jackets and gold pants, and everyone in Discord will be there. And yeah, it's gonna be incredible. So that is a Feel Strong, man, and it doesn't get any better than that. So I think we should jump into the session. So I think we were doing a problem called remove letter to equalize frequency. This problem ultimately was very convoluted, but it forced us to get out of autopilot to solve it, which was always a good thing. Time complexity ended up not being that awful in the end as well, which is even better. So we can't ask for much more than that, honestly. And then we have yes, it is easy. Easily the most frustrating problem on LeetCode, and that is definitely true. But we should definitely check out. Oh, there's no solution. Well, I guess, yeah, I guess we'll just, there's no accepted solution, so I'm satisfied with what we chose. We've already done this problem. We're still running from projection. So let's just go to the next one. We have binary number with alternating bits. Have we done this problem? We have done this problem. Let me just refresh the page. So we have maximum products of two elements. Projection area, we're still ducking, and we'll try binary gap as well as count good triplets, which already sounds like a version of threesome. And then, yeah, let's see how this goes. So we have to find the maximum product of two elements in an array. Given the array of integers nums, we will choose two different indices I and j of that array. Return the maximum values of num sub I minus 1 times num sub j minus 1. Num sub I minus 1 times num sub okay, so it's num sub I minus 1. So we're actually subtracting the number itself. So we actually take 5 and 4, I think. Indices I equals 1, right? You would get maximum value is num sub 1, which is 4. Minus 1 gives you 3 times num sub 2 minus 1, which gives you 4. 4 times 3 equals 12. I'm presuming the next answer we have 1, 5, 4, 5, and the answer is 16. It feels like the answer could be gotten if we sort the array, which would take n log n time, or you could get the maximum value, which you could do in 2 iterations of linear time. So that could be pretty cool. So I wonder if you take if you just sort the array, you could just take the top 2 numbers, subtract them by 1, and return that. We also don't know how long the array will be. We're guaranteed at least 2 elements. Maybe we're safe. So we'll sort them in ascending order, and then from here, we can just return num subs. Actually, it might be easier if we just do it in reverse. We'd have to write less characters. So if we do it here, we get 5 and 5. Subtract 1, we get 4. You'd have 5 and 4 here, would get 12. I feel like this makes sense, but I feel like it's almost too simple. Okay, we will take that. I think you could do linear time with constant space as well if you were to just iterate through both times to get the 2 max numbers. But we're looking for special positions in a binary matrix. Special positions in a binary matrix. Given an m by n binary matrix mat. Given an m by n binary matrix mat. Given an m by n binary matrix mat, return the number of special positions in mat. Position I, comma j is called special if mat sub I sub j equals 1 and all other elements in row sub I, column j, mat sub I sub j is equal to 1, and all other elements in row I and column j are 0. Well, the maximum that there can be based on this rule must be n, right? Or the minimum of m times n. If there's only 3 rows and there's 4 columns, right? The maximum different number of n's that you could have, such that they don't break the rule of having the same number in the same column and row, would be the minimum of the rows of the columns. So what we could do is create a set for all the rows we could create a set, a map actually, of row or column to numbers to rows that have a 1 in them, right? And we'll know if a number, if a cell is special, if for that cell, right, the 1, the number that does exist in that cell is the row itself or the column itself, and the length is 1. If there's more than 1, then that would be an issue. I guess I was thinking of we could do it in less time if we didn't if we use no space, we could do it faster. Because you could just say every time you find a 1, right, check. If we can't find another 1, if we do find another 1, we'll subtract it from the max. Similarly, we could add a bunch of special cases to skip. If you find a 1 in a row, it's simply impossible for that other elements in the row to be special. So then we can just iterate through the entire matrix. If we find a 1, we're going to start from the beginning of that row and make sure that there's no other 1s besides that 1, and we'll go through all the columns to make sure there's no other 1s in that column. We are back. I actually felt like I was going to die. So I just threw back an entire bumblebee. So this is a bumblebee. It goes crazy. We just threw one back, and then I threw back some sun chips. I'm feeling energized. So I think what we said we were going to do, I think we're just going to iterate over every cell in the matrix. While it looks like we're not guaranteed that the matrix is going to be square, so we're going to have to make sure to respect that. So you do mat sub row, column must be less than mat sub row, through call plus plus. Now we can say if mat sub row sub call equals 1, then we can do the work that we said we were going to do. And we'll say right? If the row in the column doesn't contain one, we'll pass in mat, the column we're in, the row we're in, right? And that would be the column row combination that we would try to, or the row column combination that we would try to exclude from looking when we write this function. Then we want to do special plus equal 1, and then we can write a function called call and row contains 1. It's going to take a matrix, which is a number array, a row, and a column, and it's going to return a Boolean right? And so now we can basically copy both of these. So given the row that we're in, right, row is going to be equal to 0, and we're going to go through all of them, and row is going to be less than mat.length if row does not equal r, and mat sub row, right, sub c equals 1, we're going to return true. Then we can do the same here for column. We're going to say call does not equal c, mat sub r, and this could be a mess, but we'll see. Seems to work. So we'll try binary gap. Given a positive integer n, find and return the longest distance between any two adjacent ones in the binary representation of n. So we're given an integer n, which is positive. We have to return the longest distance between any two adjacent ones in the binary representation of n. What does it mean, the longest distance? If there are no two adjacent ones, return 0. Two ones are adjacent if they are only zeros separating them, possibly no zeros. The distance between two ones is the absolute difference between their bit positions. For example, the two ones in 1001, which would represent 1, 2, 4, 8, 9, have a distance of 3. It seems like what we generally want is to just keep track of the first one and then the last one. And if their indexes are the same, we'll return 0. And if their indexes are different, we'll return the difference. And I think that would be okay. I guess the difficulty would be finding the first one. So we'll let first one index equal -1, and we'll let second one index right? We know that the numbers are 32 bits in JavaScript, I think. So we'll try this in reverse. So for I is equal to 0, I is less than 32, I plus plus. We say if n and I, right? This would mean that we have a 1, right? We have to check if first one index equals -1, right? It means it's not set yet. If it's not set yet, then first one index equals I. Else, if it's already set, right, then we should say second one index equals I. So this should give us the last one. And then I think we should be able to check, right, if second one index, if second one index equals -1, or if first one index equals -1, it means there's no ones in the number, right? The number would be 0. Or we could also just say if n equals 0, return 0. So that would save us that problem. But similarly, if only one of them is set to -1, we should still return 0 because it's not possible. And I think we should be able to return the absolute value of the difference. Maybe not. So our output, oh, we forgot to shift the bit down. So n is going to equal to n bit shifted once. So it seems to work in the first case. We would return, when we have 8, which would give you 1. Oh, not n and I, and n and 1. So in the case of 22, 22 is represented like so. We would have 1, 0, 1, 2. So we have this one be 1, 2, 3, 4. 4 minus 1 would give you 3. Something seems off here. In the case of 5, is represented as 1, 2, 4. So you'd have 4, 1, 0, 1. They want 2, which doesn't make much sense because it's separated by 1. So maybe they want how many spots away it is. But if you take something like 22, what we get is 1 minus 0, 1, 2, 3, 4. You would get 3. But the answer they want for this one is 2, which doesn't make any sense to me. This makes me feel like if the difference if the difference is less than 1, if the distance if the I don't understand what this problem is asking me. It seems like you're talking about two adjacent ones are adjacent if there are only zeros separating them. Oh, if there are only zeros separating them. But they expect 1 here. In the case of 7, there are no zeros. There are no zeros at all. So shouldn't the answer be 0? Seven has no zeros. 1 in 1, 2, 4. That doesn't, yeah. The album has a lot of dislikes. It seems like they want us to band around as well. But even then, that wouldn't make much sense. Oh, any two adjacent ones. Wait, even if that was the case, it still wouldn't make any sense because there's no zeros in 7. 1, 2, 4. Right? The 4-bit would be turned on. You have the 2-bit on, the 1-bit on, which would give us 7. So how are we still getting 1? This doesn't make a lot of sense. I don't understand. This is not making a ton of sense. If there are no ones, I think what they're trying to say, if there are no zeros separating it, if it has no zeros, So we need to figure out the most significant bit. That to be the case, we have to start at power equals 32. Power is less than or is greater than or equal to 0. Minus equal 1. We'll say if 2 to the power and n So now I have the most significant bit. Now we'll be able to know, say 4i is less than MSP index let's say has all zeros has all ones equals we'll assume we have all ones. Otherwise, if we don't, fine, we'll say has all ones equals false. If we don't have all ones, it means we have a mix. However, if we have all ones, we should return 1. And this should get us past that one case. And we're back to 22, which doesn't make any sense again. Oh, I think I know how we can do this now. I think I understand what it's asking me, but I think I'm a little fried to implement it. So I think we can do it tomorrow.